Again, apologies over Zoom. I guess we're just not getting the link up. So tonight we're fortunate to have with us the North American Woodpecker expert. He returned from Borneo just this last week, where he spent 6 weeks looking for birds there. And I was talking to him earlier, and he said this was his 6th trip to Borneo. So I thought he might, inadvertently mention an orangutan in his program tonight. You'll have to ignore that because he's probably still got his head into Bornean bristleheads and things like that. Anyway, please forgive him for those things. He lives in Sisters, which is the home base for 11 species of woodpeckers. One of the few places you can go to see 11 species of woodpeckers all in one day, all in a relatively small area. He founded the Woodpecker Festival in 2008. He is also the co-founder of the East Cascades Audubon Society, and he's the co-founder of the Oregon Birding Trails program. He also put together his woodpecker knowledge into a book. It's the Peterson Reference Guide to the Woodpeckers of North America. That is the place to go if you have any questions about woodpeckers, or come here tonight and talk to the expert himself. So let's please give a nice warm welcome to Steve Shunk.
Thank you, Dennis. Thanks to all of you for coming tonight. Thanks to the board at Lane County Audubon for having me here. It's a great opportunity. I love talking in public. I hated the whole pandemic Zoom thing. So forget about that Zoom stuff. There's nothing like being in front of people. Just no comparison. So I'm really happy to be back out on the road, on the circuit. Here we go. I can see it. So I did write this book. I'm very proud of it, but I hate to tell you that they're out of print. But you can probably find used copies online, and you can also get it on Kindle if you have Kindle. And I think you can get a Kindle app for your phone, so you don't have to have a Kindle machine. But I'm not a Kindle user, so I can't say that for sure. Okay, it's for sure. I'm going to do just a tiny bit of advertising tonight. I do most of my guiding now through Naturalist Journeys. They're based out of Arizona, but go all over the world, over 100 different tours a year. And this is what I have coming up: Jamaica. This is what I've got coming up for the first 6 months of the new year. So Jamaica, South Texas, Costa Rica. I'm also going to Costa Rica this Christmas. Taiwan and the Ryukyu Islands, little tiny islands of Japan. And then 2 Oregon tours. This is my Oregon Malheur and Cascades trip. And then I also do, this is the 2nd year we're doing an Oregon woodpecker photography trip. If you're a photographer, it's an outstanding opportunity. We always have all the nest sites all staked out, and we max the group size at 6. So it's very intimate. And then we have a professional photographer, a friend of mine, Kirsten Hines, who's a phenomenal photographer and teacher. And so it's a great opportunity to look at the birds here and right on the other side of the Cascades in a different light. And I still lead tours to my own company. And I just changed this tonight because I'm actually moving to Mexico in a week. And I'm moving to Pacific Mexico. Show you a little bit about where I'm going. This is basically Puerto Vallarta, but the area where I'm going to be is south of Puerto Vallarta in an area called Cabo Corrientes. This is Cabo Corrientes. This is Banderas Bay, and PV is up here. And the place I'll be is down here near El Tuito. And you see that little green flag? That's Rancho Primavera. This is a 200-acre ranch. Amazing birding at this place, and they have lodging facilities there. So you can come fly into Puerto Vallarta. I'll come pick you up at the airport and show you around on the property. There's squirrel cuckoo, cinnamon hummingbirds, one of the, we call it the junk hummingbird because there's so many of them. Citrulline trogon, There's also elegant trogon on the property. Mottled owls, calls right above the house where I'll be living every night. Happy wren. It's a fun name. Rosy thrush tanager, real restricted range species. Again, singing and breeding right on the property there. And you don't have to go very far to see the orange-breasted bunting. It's about 45 minutes from the lodge. Pretty spectacular bird. And of course, there are some woodpeckers. There are 5 woodpecker species just on the ranch alone, including this. This is a West Pacific Slope endemic golden-cheeked woodpecker. Also another endemic, the gray-crowned woodpecker. And there are a couple of big woodpeckers on the property. The pale-billed and the lineated are both resident and breeding on the property. And this is the closest remaining relative to the ivory-billed. Amazing bird to watch. Just amazing. Just right next to the main ranch house. So if you need to get a hold of me, my email is easy to remember, steve@paradisebirding.com, and there are some business cards on the back table. Okay. I start most of my woodpecker shows with this quote: "It is generally agreeable to be in the company of individuals who are naturally animated and pleasant." I think you would agree with that. "For this reason, nothing can be more gratifying than the society of woodpeckers in the forest." Spoken by John James Audubon. And tonight we're talking about woodpecker anatomy and adaptation. And that's a white-headed woodpecker skeleton there. So woodpeckers are amazing birds. They're fun to watch, captivating, conspicuous. This is a 3-toed woodpecker slamming its head into trees. And they are very specialized, one of the most specialized bird families in the world. And the extent of the specialization is going to blow your mind. The things I'm going to tell you tonight are hard to imagine, but almost every part of the woodpecker's body is specialized for the woodpecker lifestyle. And this is just part of it. There's feeding, but then there's also the nesting behavior. And if you think about it, this is a complicated process to start with the fresh outside of a tree and to excavate the beginning of a hole and to then have to scooch in there and toss out the wood chips. And at some point, eventually, you have to go in even farther. And you can see the tail feathers sticking out there. This bird has to back out of what's been excavated so far. Look at that. That's a lot of work. Okay. And it's hard to really imagine it. This is what happens once it's more open inside. This is a hairy, and they can then clean it out from the inside. But it's hard to really imagine this unless you can see the actual cavity. So this is a red-breasted sapsucker cavity. A friend of mine had to cut a tree down, or a friend of his had to cut a tree down, and this bird had nested in there that year. And you can get a better idea about what it takes to excavate a nest cavity. It's a lot of work. And not only do they excavate for their nest cavities and excavate for food, but they also slam their heads on trees when they're drumming like this. So why don't woodpeckers get headaches? That's the big question. There's even a book called that. It's just a general trivia book, but I think the title of the book is "Why Don't Woodpeckers Get Headaches?" So that's where we're going to start tonight. So everybody recognize this? Good. Very good. Somebody's quick. And this is your head. It looks like my head, but I want you to think of it as your head. Okay. And if you were to hit your head against that brick wall with the same amount of force that a woodpecker does, you'd have to be going 16 miles per hour and exerting 1,200 Gs of force. Imagine that. Fighter pilots basically tolerate like 10 Gs. Okay. And that's about the limit of what humans can tolerate. I think maybe we could tolerate more than that in certain situations, but not 1,200. So the deceleration forces of 1200 Gs require some very specialized anatomy. So we'll start with the head structure, okay? Because that's where the hammering is done. And it's all about protecting the soft tissues of the head, mostly the eyes and the brain. When scientists are studying about how to make safer football and motorcycle helmets, they study woodpeckers. So all the science, the latest science that goes into safe football helmets that you're learning about and seeing on TV these days, it's all coming from woodpecker research. And the first thing to know is related to cerebrospinal fluid. Okay, I'm just going to call it CS fluid, cerebrospinal, because there's too many syllables in that word. Okay, so humans have a lot of cerebrospinal fluid. And basically, our brains are sloshing around in a bath of CS fluid. Okay. And that's fine when we're walking around. But the problem with that is when we are subject to impact is that the brain sloshes and it slams forward and against the skull. And that's why it's so easy for us to get a concussion. Woodpeckers have almost no cerebrospinal fluid in their cranial cavities. So their brains are very tight inside the cranium. So there's no movement occurring. When we get in like a car accident, at first we have the initial impact, the permanent impact right here on the frontal bone of our brain, of our skull. And then we often remember, this is one of the laws of Newton's laws, where for every action, there's an equal and opposite reaction, right? So then you get a secondary impact of the brain going against the back of the cavity here, the cranial cavity, the occipital bone. Okay. So when we're getting concussions, woodpeckers are not suffering the kind of damage that we do. And in the large part, this is because of the lack of cerebrospinal fluid, or the minimal cerebrospinal fluid, and the bony fibers in the frontal and occipital bones here and back here. And you'll hear people say that it's spongy, but I don't like that analogy because that makes it seem soft. It's not really soft, but there's this network of bony fibers that helps distribute the energy. Okay, if it were solid bone, you can see that the energy transmission would be almost 100%. Instead, it's got those bony fibers in there that help distribute energy to take that impact away from the brain. Then some woodpeckers have an extended frontal overhang, and I'm going to show you another schematic here in a minute. The woodpeckers that do the most excavating, so that what I call the heavy duty excavators, have a big frontal overhang, and those that don't do as much excavating, like a flicker, they do not have a frontal overhang. And I'll explain that in just a second. Each of the different woodpecker genera and each of the species has a little bit different shape to their cranium to accommodate their different lifestyles. So notice the shading, the shadow here, 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 and here. Okay, those are the frontal overhangs. Notice that these birds here and this one have no frontal overhang. So those are the weaker excavators. That the heavier duty excavators have that frontal overhang, because what that does is they have a special hinge in the upper mandible. And with that frontal overhang, when they slam their heads against the surface, the resultant forces are directed downward because of that frontal overhang, away from the cranial cavity and into the torso. The torso can withstand that kind of force, but the brain cannot. So the frontal overhang helps facilitate the protection of the brain. Here's a different way of seeing it. And again, you can see that the Dryobides and Spheropicus genera have a big frontal overhang. They're doing the most excavating. You think about sapsuckers, they don't dig very deep, but they're slamming their heads against the tree constantly, making sap wells. These guys up here are doing more excavating for food. Okay, these guys down here really prefer, when they're making nests, excavating cavities, doing it in really soft, rotten wood. Okay, because they don't have the adaptation to excavate in harder wood. Also, if you look at the top, you can see the frontal overhang here and here, But also notice that the width of the bill is broader, and that also helps distribute forces over a wider area. And the nares, or the nasal openings in the bill, are off to the side and elongated. So that helps prevent debris from going into the nasal openings. And notice again, the lower genera here, they have different nasal openings because they're not doing as much heavy duty excavating. Okay. So just to show you a couple more examples, you can hear the babies. Beep, 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 beep. So the birds that are doing more hammering, like this white-headed woodpecker, they have the frontal overhang. They've got the broader base to the bill and the nares off to the side. The flickers, this happens to be a South American flicker. It's actually called a spot-bellied woodpecker, spot-breasted woodpecker. But this is how flickers feed in the ground. That's not very heavy duty, right? So the structure of the skull is completely different. They do lack the frontal overhang, and the nasal openings are larger and set up on top, and they have a narrower base to the bill. A few other skeletal features to point out. I'm going to talk about the tongue in a minute. This part here, that's the those are the hyoid bones. These specialized ribs, woodpeckers have special ribs, and the more heavy duty woodpeckers, like the blackback especially, they have a very tiny first rib, and then the second rib is extra large and has an extra large connection to the spine and the septum, because they have a separate specialized set of muscles that go from those ribs up into the head and neck to help deliver the blows, and then to redistribute the resulting forces downward into the torso, away from the cranial cavity. Pretty amazing. Also, woodpeckers have a shallow keel. This bone in the front, like waterfowl have a big keel. They're big flyers, right? Woodpeckers aren't big flyers in general, so they don't need those big muscles. Instead, they want to be closer to the tree when they're excavating. So they have a shallow keel that helps facilitate that. They also have a special set of fused bones at the base of the base of the spine here called the pygostyle. And on the heavier duty excavators, the pygostyle is broader and larger because those muscles attach to the tail feathers, which allow the bird to prop up against a tree. So it has 3 points of contact and the leverage to bend all the way back and bend forward to hammer against the tree. Okay. So that's the skull. We'll talk about the eyes a little bit. This is Dr. Ivan Schwab. He's an ophthalmologist at the University of California at Davis, and he won an Ig Nobel Award. You may be familiar with the Annals of Improbable Science. I don't know, have anybody heard of that? Okay, they put out an award every year called the Ig Nobel Awards, which are kind of silly, not silly, but unusual science discoveries. And he won an Ig Nobel Award for showing why woodpeckers don't get retinal hemorrhages. And that seems kind of silly on the surface, but if you're trying to learn about retinal hemorrhages in humans, why not study an organism that is subjected to tremendous forces? So it's perfect. And one of the things he showed, the main thing he showed, is that there are these two organs in the eye of woodpeckers, the choroid and the pecten. Now, other organisms have choroid, and I'm not sure about what other organisms have a pecten, but in woodpeckers, this pecten is a critical piece of the eye anatomy. And what he showed was that the moment before the woodpecker's head contacts the surface, the choroid and pecten fill with blood and a mucopolysaccharide protein to increase the intraocular pressure in the eye before the head contacts the surface. That prevents the eye from pulling away and tearing the retina. It must have to do with the angle of approach. I don't know anything more about it than the fact that it happens, but I'm sure it has something to do with the geometry. And, the woodpecker knows when its head is going to contact that surface, but it's got to be an involuntary process. I don't think that it consciously makes that happen. So anyway. Yeah. Pretty amazing. It also, woodpeckers have a thicker orbital septum, the bony piece between the two orbital sockets, and that allows them to have a stronger set of muscles around the eyes than most birds, that help protect the eyes from the impact. And they have thicker nictitating membrane and a thicker eyelid than most birds, and that helps protect the eye from debris flying back in their face. Okay. And in the flicker, this is a particular advantage because the flicker is one of only 2 woodpecker species that feed by regurgitating. And when you're feeding a young woodpecker and you stick your whole head inside a baby flicker's mouth, you have this problem of the baby flicker's bill poking toward your eye. So having a thicker eyelid has a particular advantage. All right, the tongue, the extensible tongue. Scientists have been fascinated by the woodpecker tongue for centuries. Borelli was a contemporary of Leonardo da Vinci, and da Vinci was the first one that we know of to verbally describe the woodpecker tongue structure, but Borelli is the first one that we know of to have actually drawn the woodpecker tongue. So this is from about 1675, and it's not entirely accurate to what we know today. And it's probably from a green woodpecker, which is a common Eurasian species. But the thing to notice here is how one of these muscles wraps around the trachea. And when that bird would stick its tongue out, that thing would unwind and rewind every time the tongue was extended and retracted. Today, we have much fancier technology like this digimorph technology, which is basically a CT scan for not just animals, but they use it for geology and other purposes, botany, zoology, geology. And this is where that spinning white-headed woodpecker video came from, the same kind of technology. So we can look inside these skulls, and actually the one you saw with the frontal and occipital bones and the frontal overhang earlier, that's also digimorph. So they can get slices at any point through the scan. And the red part here is the bony part of the tongue called the hyoid. It's not really a hyoid bone. Now let's talk about the hyoid for a second. So humans have one bone at the back of our throat here that helps us extend and retract our tongue. It's called the hyoid bone. It's the only bone in the human body that doesn't have a joint. It's not attached to any other bones. Okay. And as you move your tongue in and out, that hyoid bone is attached to some muscles that helps it go in and out. That's not good enough for the woodpeckers. The woodpeckers have a hyoid apparatus, which is a set. Now, you don't have to memorize these words here. The blue are the names of the bones, and the red are the names of the specialized muscles. And woodpeckers have muscles that don't exist in any other organisms. Some of them are similar, but they have several that are totally unique to woodpeckers. And the hyoid bone system has two bones make up the epibranchial. There's a set of fused bones here. There are 2 bones that make up this section, and this is a set of fused bones here at the paraglossum. These muscles here help retract the tongue and help wiggle the tip of the tongue once it gets inside looking for food. These muscles here help extend the tongue. So these bony parts are completely wrapped in muscles. And then these muscles here also help retract the tongue. So they've got a whole set of bones and muscles that are specialized. So the sapsuckers have the shortest of all the tongues because they really only have to stick their tongue as deep as the deepest sap well, which isn't very deep, right? So the sapsucker's tongue, when it's retracted, only goes about to the back of the head. Okay. And then every time it sticks it out, that thing unwinds and rewinds. Okay. On the other hand, the other extreme, we have the flicker. Okay, the flickers have the longest tongue of any woodpecker, probably the longest of any woodpecker in the world. Now, this is a juvenile flicker, and you can tell its tongue goes all the way to here. Okay, that's hard to imagine unless you can see it visually. So when the flicker's tongue is retracted, it goes back from the tip of the bill, splits into two, forming that Y. The two parts of the tongue go back over the head. Here's where the sapsuckers ends. The flickers goes up to here. Most woodpeckers end right about here. The flickers keeps going into the nasal opening and into the upper mandible. So when a flicker's at rest, both the terminal ends and the tip of its tongue are in its bill structure. It always makes my nose hurt. Pretty amazing. And again, many times a second, that tongue can extend and retract when it's feeding on ants, sticking that tongue into underground burrows. Yeah. It's underneath the skin, but it's outside the cranium. So if you took the skin off the woodpecker, you'd see the hyoid right there. And yeah, and bird banders, have any of you ever banded? Then you know what I'm about to tell you. When you're blowing on the back of a head of a woodpecker, you can't judge how much fat is there because the hyoid apparatus goes up across the back of the cranium, and you can't tell how much fat is there because it's over the fat. Yeah, pretty amazing. It doesn't stop there. Okay, we have the hyoid apparatus, but then we have the fleshy part of the tongue. That we haven't even talked about that yet. Okay, just the main structure. But different species have specialized structures on the fleshy part of their tongue, depending on their feeding behavior. So I've got several examples here. The Lewis's woodpecker, as well as the acorn and the red-headed woodpecker, are specialized at fly catching. That's their primary feeding behavior. Okay. And when they're fly catching, they catch an insect on the wing, call that hawking, and then they can hold that prey down in their bill while they open their bill to catch more insects. In order to do that, they've got an extra wide tongue with this rough kind of mixed set of little protuberances at the tip. Those are made of keratin, just like our fingernails. And this is kind of a sandpapery surface here, and those bumps also are made of keratin. So in general, it's that tongue is used to retract the prey into the bill and to hold it in the bill while it catches more prey. Okay, that's a fly catching woodpecker. Then we have the flicker, which is eating what? Ants, right? The flicker eats more ants than any bird in North America. Flicker sticks its tongue down into this ant burrow. It doesn't need those rough barbs at the tip, so it doesn't have any. Instead, it's got this long sandpapery section here and a special submaxillary, the maxilla is the upper mandible, submaxillary salivary gland. And every time that tongue gets stuck out, it gets covered in sticky saliva and goes down into that ant burrow. And then the ants get stuck to the tongue. And when the tongue gets retracted, they get removed from the tongue and ingested. Okay, so that's another specialized tongue. The sapsuckers have one of the biggest questions, most common questions I get about sapsuckers is, do sapsuckers excavate sap wells to attract the insects? Okay, and I have actually more often than that, people come up to me and say, oh, I heard that sapsuckers excavate sap wells for the insects that come to the sap. We know that that's incorrect, and you can help me spread the word. Okay, we know that's incorrect because this bird has an anatomical adaptation for collecting sap. The tip of the tongue of the sapsuckers looks like a little paintbrush. Little tiny hair-like protuberances sticking out, perfect like a paintbrush, and it takes that tongue tip and swipes it through sap wells to collect sap. Perfect mechanism for collecting sap. If this bird was doing it to collect insects, it would have the barbs on the tip, like some of the other woodpeckers. Instead, we know that it's adapted for eating sap by looking at the tip of its tongue. Okay. And the last example is the blackback woodpecker. And this bird eats, does anybody know what the blackback woodpecker's favorite food is? Wood-boring beetle larvae. 90% of the diet of the blackback woodpecker is wood-boring beetle larvae. So this is probably the most heavy-duty woodpecker in the world. This bird has all the fancy adaptations for hammering its head against hardwood because it's going into the depth of the wood to get most of its food. It's not probing or gleaning on the surface or in the cracks of the bark. It's not going behind the bark to get bark beetle larvae, although it will eat bark beetle larvae. It's going into the wood of the tree to get wood-boring beetle larvae. So what's the best way for you to extract that prey? Well, you have a thinner tongue tip, and that tongue tip goes down between the larva and the wall of the larval gallery. The larval gallery is the tunnel that's been eaten by the larva. That tongue goes in between the wall of the larval gallery and the larva itself, and it has backwards facing barbs like a fish hook. And when it pulls back on the tongue, it hooks on the surface of that grub and pulls it out of the gallery. Amazing adaptations. And there are a couple other variants on this depending on the species, but they have the amazing adaptation of this whole hyoid apparatus, and then you get down to the nitty-gritty and they still have even greater adaptation at a whole different level. All right, we're moving down the body. Okay, we're going to get to the feet, and there's another kind of misconception about woodpecker feet, and I will clear that up for you tonight. So most people will say that woodpeckers have zygodactyl toe arrangement, which means toes number 2 and 3 go forward and toes number 1 and 4 go back, like gripping like this. Okay. The problem with that for woodpeckers is that that's a perching adaptation, right? Most perching birds have 3 forward and 1 back for grabbing. Having 2 forward and 2 back is for grabbing, not for climbing. Anybody a rock climber? Some of you have rock climbed, I presume. So when you're climbing, do you hang on underneath like this? So having toes that point backward is really not going to facilitate your scansorial lifestyle. Scansorial means climbing. Okay. So instead, most of the woodpeckers, now some of the woodpeckers have a zygodactyl foot like the flicker because they spend more time on the ground. And when they land in a tree, you're more often going to see them perched in a branch than you are vertical on the trunk. They will land vertical sometimes, and they'd have to when they go to a nest cavity, but that's only a very short part of the year. Most of the time they're on a surface. The rest of the woodpeckers have a more specialized toe arrangement. And I want you to notice, I've got a series of slides here. So notice the positions of the toes on this hairy woodpecker. Okay. Notice that the 4th toe, the long one, and the hallux, the number 1 and number 4 toes, are swung around to the side. Okay. So when you're rock climbing, holding out here is more common than holding down here, right? You can hold out to the side, and kind of this 90-degree area right here is really what's best. And that's what most of the woodpeckers use. And we call that ectropodactyl. Okay. What that means is outer movable toe. So the outer toe is movable based on your circumstance. So now look at the toe arrangement on this hairy woodpecker. Based on the position of the bird around that post, it can manipulate its toes. So that's not a zygodactyl toe arrangement, right? Form follows function, and the function of this bird's feet is to climb. And so if we said that it had zygodactyl toes, it would be incorrect. If you hold this bird in your hand, if you're banding and you hold it in your hand, the relaxed position of its feet will look zygodactyl. But that's not a functional position, right? It's just a relaxed position. What's specialized is the bird has special muscles that allow it to swing those toes around to the side. And take a look at this downy, and look at all 4 toes are swung around to the side, and look at how the hallux is not even being used. It's laid flat against the tree. It's not an advantageous adaptation to have that 4th toe. So there actually are woodpecker species that never had a fourth toe. Those that spend their whole lives in the vertical plane, in particular in North America, the black-backed and three-toed woodpeckers both have only 3 toes. Okay, and this is because they climb all the time. That's where their food is. Remember, 90% of this bird's diet is woodborne beetle larvae. So when he's climbing, he doesn't want that fourth toe. It just never worked out. They have 3 toes. Okay, so even though he's not called three-toed woodpecker, he is a 3-toed woodpecker. Okay. All right, so we talked mostly so far about structural anatomy in the internal parts, and let's talk a little bit about feathers. These are both hairy woodpecker wings here, but you can see that eastern and western hairy woodpeckers have different adaptations. This is an eastern bird and this is a western bird. And hypothetically, or the theory there would be that the western birds are in deeper, darker forest, and so they have darker wings. And the birds in the east are in more mixed woodland, and so they have mixed speckles on their wings, so that they're better camouflaged in that in the broken light of an more open forest. But one of the other parts of the feathers of a woodpecker that are unique are the nasal tufts. And the birds that are the heavy-duty excavators tend to have more nasal tufts. So you can see these here on this hairy blocking off the nasal openings, right? So that helps, again, prevent debris from going into the nasal openings. And notice the flicker on the right, no nasal tufts. Even though he's sticking his bill on the ground, remember, he doesn't have to stick it very deep because he's got that extra long tongue. All he has to do is get to the entrance of the ant colony, and the tongue does the work for the flicker. So no need for nasal tufts, so we don't grow them. All right. Another specialized set of feathers for the woodpeckers are the tail feathers. And if you're ever in a banding station or you get to band woodpeckers, you can see and feel the tail feathers are truly unique. They have very stiff feather shafts or rachies, and they have no barbs at the tip. The barbs taper off toward the tip of the tail, because that also wouldn't serve you to have a fully barbed feathers on your tail if you're dragging your tail up the tree the whole time. Okay. And there's a couple other things related to the feathers. The feather arrangement and the feather shapes of a Lewis's woodpecker are different because he's a fly-catching woodpecker. So this bird flies better than most woodpeckers. And it also is one of our migratory woodpeckers. So having better flight adaptations is better for this bird. Okay. And then maybe the strangest thing about the feathers of woodpeckers is not the feathers they have, but those that they lack. And what do you see that's missing from these baby red cockaded woodpeckers here? What kind of feathers are missing? Down. There's no down. All their regular feathers have already erupted. Look at this. These are all the eruptions of regular feathers coming out. So woodpeckers do not have any down. No down. Adults and babies. And that's probably an adaptation for spending the coldest parts of the day inside an insulated cavity. So if you don't need to have those feathers, you don't grow them. Right? It would be disadvantageous for you to spend the energy to grow an entire set of insulating feathers if you didn't need them. No down on woodpeckers. Okay. So that's not even all of it, but that's about as much as I can give you in one night. That's enough for you to take that home. So woodpeckers are cool, obviously, but lots of birds are cool, right? Woodpeckers and trogons are cool, and hummingbirds are cool. Raptors are cool. So what? What's the big deal with woodpeckers? Well, beyond our fascination with woodpeckers, woodpeckers play very important roles in our forests. So the last part of my talk here is about ecology and woodpeckers and how they fit into their environment. So the first thing to understand is this arch here. And what do you call this right here? The keystone. Okay. And what happens if you take the keystone out of an arch? It collapses. Okay. So woodpeckers are what we call keystone species or keystone organisms. And I'll give you two definitions. And I've tried really hard to word these clearly, non-scientifically. So a species that has a disproportionately large effect on its environment relative to its abundance. So you only need a few woodpeckers to have a big impact on the environment, on their interior environment, okay, on their habitat. And one other way to describe it, a species on which other species in an ecosystem depend, such that if you took the keystone species out, it would detrimentally affect the ecosystem. Okay, so woodpeckers are what we call multiple keystone species, and they serve multiple keystone roles. That's relatively unusual. A lot of organisms are keystone species, but woodpeckers have special roles. One of them is providing food and affecting migration. Sapsuckers excavate sap wells, and hummingbirds follow the sapsuckers north in migration. So in the west, the rufous hummingbirds follow the woodpeckers up north. In the east, the ruby-throated hummingbirds follow the yellow-bellied sapsuckers north. So their whole migration timing is based on following the sapsuckers. That's having a profound effect on those hummingbirds' lifestyles. Also, we talked about wood-boring beetle larvae. Okay, this is an western-eyed elater, the family Elateridae beetles. This beetle's larvae are predaceous. They actually depredate the larvae of other wood borers. And they're big, they're fat. So it's been shown that woodpeckers can consume up to 2/3 of the larvae in an infested forest. That does have a profound impact on that forest. It allows those trees to be standing much longer, which benefits multiple organisms in different ways. But what is a woodpecker's primary keystone role? Well, that has to do with this species and this one and this species and the flammulated owl. What is the connection? Cavity nesters need woodpeckers. Okay, there are more than 40 species of birds in North America, not counting the woodpeckers themselves, that depend upon woodpeckers to excavate their nest cavities. And if you took the woodpeckers out of that equation, those birds would have no place to nest. Okay, they have evolved using woodpecker cavities. And they will carry material into the cavity, but they don't make cup nests or any other kind of nest other than using those cavities. But we have an ecological conundrum, and we'll bring it to science. Okay, it's all about science, right? Humans need habitat too. And so we've transformed our forests and our woodlands to accommodate our species. And we've planted trees. We've taken trees down and then replanted nice, pretty trees. Nothing against nice, pretty trees. They've served their purpose. But we also plant trees. We cut down trees and plant them for wood products, because we all use wood products. How many of you used a wood product today? I did. More of you should have raised your hands, I think. We all need wood products. We need them for our houses, for many purposes. When we have a fire, we tend to go in and cut the trees out of the fire right away, take them out of there so we can get the timber value out of them. Now, that doesn't happen as often in Oregon as it does in California and in the southeastern US. Oregon has this unique forestry rules based on the Northwest Forest Plan, which I won't go into tonight, but that helps prevent some of the post-fire salvage logging that would occur here without it. Okay, because of the Northwest Forest Plan, we get to keep more of our burned timber than they do in other places. But in those other places. This is a California photo. The timber is taken in large amounts, and these trees in the middle, that orange paint on there is a W, showing that that's a wildlife tree. It's not very effective, and the first winter storm that comes is going to take those trees out of there. Also, when we cut trees, we tend to cut them at the base. Okay, and that's not necessary. So what's the result here? Something is missing. What part of the habitat? Snags. Cavity dwellers need woodpeckers, but woodpeckers need snags. Remember, not all the woodpeckers are heavy-duty excavators. Some of them need soft, rotten wood in order to excavate those cavities, to provide cavities for the other organisms. Okay? So we've got a few strategies that we can follow. One is snag retention. So in those burn forests, we want to keep those trees standing as long as we can. They provide a lot of habitat value. Those wood-boring beetle larvae sometimes take up to 4 years to go through their instars or their molts to emerge as adults. So the first 4 years are really important for several woodpecker species for getting those wood borers out of there. Then if we keep leaving those trees standing, at least as long as they stand before they fall due to winter winds, then they'll provide cavities for that much longer. We can leave trees standing, especially in park areas like this, and we can top them. And when we top the trees, we can top them up high. It's more difficult. It's more expensive, and it's more difficult and not as safe to send somebody up a tree or to send a cherry picker up there to cut the tree at the top. But it does provide habitat value as opposed to cutting the tree at the base, like we saw earlier. And this tree that I'm showing is in Bend, Oregon, and had a flicker nesting up in the top of that cavity there. But you don't even have to go up that high. This stump is only 6 feet, cut at only 6 feet, and a flicker nested in there. So you don't have to cut them up, 50 feet, but the more you can leave, the better. I know that sometimes your homeowners association rules don't allow you to keep dead trees. That's kind of a problem. Like we were saying earlier, in our cities, we tend to have all live trees, and that's okay, but that's not a healthy functioning forest. A healthy functioning forest has seedlings, saplings, small, medium, and large trees, big mature trees, and dead and dying trees, as well as downed trees. That's a healthy forest. In order to sustain the ecology that we've talked about, we've got to have all those trees. Another technique we can use is snag recruitment, which is a funny term for killing trees. And we're putting a lot of effort into planting trees, so it sounds odd to say we can go out and kill trees. But in a woodland where all the trees are alive, again, that's not a functioning woodland. If you want to facilitate or speed up the process, the natural process, you can girdle the trees or inject fungal spores into them, or you can top them, and that'll facilitate the rotting of that tree and make it available to the excavators sooner. But the number one most important thing for us to do is to restore and conserve a broad succession of age classes. And again, a healthy forest has seedlings, saplings, small, medium, and large trees of varying sizes, and big mature trees, and snags and down trees. That is what a healthy forest looks like. So when you go into the Cascades and you're looking at a big stand of Doug fir and it's all the same age, you know that that's been cut before and planted, and it's probably not functioning very well as a healthy forest. When you get up into wilderness areas, things are a little different because you can't take chainsaws into wilderness areas. So the trees tend to have more of their natural structure, and you tend to get better mix of age classes. Sometimes down at this elevation, you have to intensively manage in order to get a broad succession of age classes. That's very difficult to do, but it can be done. But what can you do? Okay, you can get involved with your park service. This is a park in downtown Sacramento. You can work with the park services whether it's a county parks or city parks, and get them to top their trees instead of cutting them at the base when they have dead trees. Dead trees, I know they're a safety hazard, right? We can't have trees falling on park visitors. That's a liability problem. And we have to change our paradigm. We have to change the way we look at a forest and change the way we think of a healthy forest. And when we see a snag, we don't think that it's ugly. We think that it's healthy. It's part of a healthy ecosystem. So we've got to work with the agencies who sometimes aren't aware of how this woodland or forest functions, and get them to change the way they manage their forests. You can also support organizations that are working on science. The black-backed woodpecker research in California that went on when I took that clear-cut photo that you saw was through the Institute for Bird Populations. They've done a lot of the science on black-backed woodpeckers, and supporting these organizations is important, as well as supporting your local Audubon Society. How many of you are members of your local Audubon chapter? Okay, now not everybody raised their hand. So you need to support your local conservation groups, because they, like the state organization, are often involved in conservation and restoration in your local community. And they can provide grants sometimes for different projects. And I know we have a woodpecker project on the East Cascades that was partly funded by Oregon Birding Association, as well as our local Audubon chapter in the East Cascades. So being parts of the science is important, and being a part of the conservation and restoration work is also important. So if you can't get out yourself and be engaged in the process and doing the work, you can help support these organizations with funding. If you're really into the cavity thing, you can go to cavityconservation.com. The Cavity Conservation Initiative was started about 10 plus years ago, and they are involved to an incredible degree. In part, it's so incredible because it's basically run by one lady, and she has worked with all kinds of organizations like the county parks, the state parks, and the Western Arborist Society. I'm talking about tree pruners from all over the Western United States to get them to change their best management practices. These are people who make a living cutting trees down. And she's got them to change their whole process and instead starting to manage for wildlife. This group also, what they do is they teach kids about the importance of snags. So they have all kinds of materials you can get online to distribute to the schools about the importance of snags and what kind of organisms live in snags and why it's important to keep those standing. And they have copies of those best management practices that you can get online through another website called Tree Care for Birds, which spun out of the Cavity Conservation Initiative. So, you can hear babies again. By conserving and fostering healthy forests, we can help woodpeckers provide their keystone role. Black-backed woodpecker there. We do it for the woodpeckers and the other cavity nesters that depend upon the woodpeckers. Paramountain bluebirds. A flicker nested in that same tree. Thank you very much. We have some time for questions.
Yes, I was going to say.
Be happy to answer some questions. Over here first. Oh, wait, what were you going to say?
I was just going to say we're going to do a few questions, not a whole lot, because we are getting late. But...
Okay, over here first. It depends on the species and what the diversity of their diet is. So the species that are more specialized, like the blackback, are more heavily impacted by changes in the environment, right? The species like the flicker that eats ants is pretty specialized. Most of the other woodpeckers kind of in the middle there, like the hairy, for example, and the other Melanerpes species like the golden-fronted, Gila, red-bellied, they have pretty broad diet. So they are better able to adapt. So food is important, but also for woodpeckers, adapting to different changes in forest type is also a challenge. So they gotta be flexible with their food, but also with their environment. And the best example of that is the pileated that was almost extirpated from large parts of the eastern United States when we first came in and cleared all the woodlands. Then as the forest started taking over those agricultural areas again, when we stopped cultivating things as often as we do, the pileateds adapted to second growth woodland, which was a little unusual for them to adapt so quickly. So it's all about being able to adapt to change. So those birds in the middle of the spectrum are better off. They'll survive better than the ones that are more specialized. Yeah.
Yes, the species that eats the wood-boring larvae, have they been matched up with something like the emerald ash borer?
Yeah, it's a very interesting question. There's actually a study that's been published. Oh, the question was about the emerald ash borer, which kind of is an exotic beetle that started in the Great Lakes and is now spread all across that region, but I believe has now been found in Oregon. And emerald ash borer is very prolific, and it's a wood-boring beetle. Its larvae are into the tree. And there was a study that was done that showed the productivity effect, increasing productivity of woodpeckers based on trees where the ash borer existed. So the woodpeckers, and when they go look to try to tell what trees are infested, they look for woodpecker feeding sign, and they look for the woodpeckers themselves. So woodpeckers are helping them do the research on emerald ash borer, and in some cases they can have a positive impact by consuming a large number of larvae, but it kind of has to follow a cycle where you have to have a series of generations where the woodpeckers can respond by having more young in a given year to respond to the high amount of food. And then that has to happen again for another generation. And sometimes by that time, the ash borers have moved on. So it really kind of depends again on the region and the habitat in particular and what those what those beetles are attacking. Yeah. Sure. Population dynamics in burned areas. The woodpeckers are each adapted for burned areas at different levels. So for example, the blackback woodpecker is adapted for eating wood-boring beetle larvae. When a fire is burning, the smoke is going up. The beetles, the wood borers, can sense the smoke. They have very strong sense organs. So they can sense the smoke, and they're flying in while the trees are still smoking and laying their eggs in the bark. The eggs hatch sometimes within a few days. The larvae bore into the tree, and it takes up to 4 years for those larvae to go through their cycle. I mentioned that earlier. So that 4 years after a fire is very important for blackback woodpeckers. And high intensity fire is more important because we find higher densities of wood-boring beetles in higher intensity burns. On the other hand, sapsuckers need sap. So they don't necessarily take advantage of a burned forest, except for one reason. How would sapsuckers take advantage of a burned forest? Yeah, for nest cavities. So they have a mixed result. And thankfully, most of our fires, I mean, this is just how it happens. Fires burn in a mosaic of intensities. Okay. Whenever we look at a fire perimeter, we tend to think, oh my God, that whole thing is burned crispy. That isn't how it works. You might get big swaths burning at high intensity, but then you get patches that are low intensity or mixed intensity, or even unburned patches inside the forest. And that is actually the best scenario because you've got live trees for the sapsucker and nesting trees in the dead ones. The pileated woodpecker really doesn't like burns because the pileated eats what's its favorite food? Ants. What kind of ants? Starts with a C. Carpenter ants. Carpenter ants are most abundant in soft, rotten wood. That's why you have more pileateds here than I do on the east side of the Cascades. Okay, they have big territories on the east side. Habitat quality is direct proportional to, or inversely proportional to, the ability of that bird to thrive in that environment. And so pileateds have bigger territories where things aren't as rotten. I hate to have you think about your backyard as rotten, but it is the wet side. So the pileated doesn't necessarily benefit from a big fire because all that rottenwood burns. So it takes a while for the carpenter ants to kind of re-emerge into that stand, and then the pileated will take advantage. So different species take advantage at different levels at different times in that cycle. The Lewis's woodpecker comes in about year 4 or year 5. The Lewis's is a weak excavator. Why would he benefit from waiting? There's more cavities in that forest already excavated in those trees for that Lewis's woodpecker. So he'll take those old cavities that were excavated by a hairy or a blackback and expand the entrance and expand the inside a little bit. He's a little bigger woodpecker. And then we'll go in there and nest. And Lewis's tend to nest in loose colonies. So you get a high intensity fire and you go from about year 4 on, and you can have high density of Lewis's woodpeckers for several years. And in general, we kind of think of it peaking at about 10 years, 10 to 15 years after the fire. And then what happens is the storms over the years come and they knock those trees down. New trees start growing in and filling in, and it becomes less suitable for the Lewis's woodpecker and increases the suitability for sapsuckers and the birds that depend on the live trees. So again, it's about what your food preferences are and time since the fire and the intensity of the fire. Each is adapted for a different scenario. Thank you again.
Thank you very much, Steve. And thank you all for coming. You've been a great audience. We do need a little help putting away chairs, if you could help with that. And I guess that's it. Look forward to seeing you next month.
Yeah.